Hey, Stan.
Hello.
Hello, hello. Welcome back to Talk Python to me.
I'm glad to be here. Glad to talk
Yeah,
performance.
I know. I'm excited to talk performance. It's one of those things I just never get tired of thinking about and focusing on. It's just so multifaceted. And as we will see, even for a
Yep.
language like Python that is not primarily performance focused, there's a lot to talk about.
hmm Yeah, there's an endless bag of tricks.
Yeah.
So,
And I would say, to sort of undercut my own comment there, Python is increasingly focusing on performance since like 3.10 or so, right?
And the secret is that it's because Python integrates so well with other languages. It sort of always cared about performance in some way. It's just sometimes you had to leave Python to do it, but
Yeah,
still got to
true.
keep the Python interface.
There's been such an easy high performance escape hatch that
Yep.
making Python itself faster is obviously not unimportant, but maybe not the primary focus, right? Like
Yep. Yep.
usability, standard library, et cetera, et cetera.
hmm
All right. For people who have not heard your previous episode, let's maybe just do a quick introduction. Who's Stan?
Yeah. Yeah. So I am Stan Siebert. I am a manager at Anaconda, well-known purveyor of Python packages and such. So my day-to-day job, is actually managing most of our open source developers at Anaconda. So that includes the Numba team, and so we'll be talking about Numba today, but other things like we have people working on Jupyter and Beware for mobile Python and other projects like that. And so that's what I do mostly, is focus on how do we have an impact on the open source community, and what does Python need to sort of stay relevant and keep evolving.
I love it. What a cool job as well. Like a
Yeah,
position
I'm
where
really
everybody.
grateful. It's a rare position, so I'm really glad I've been able to do it for so long.
Yeah. And I would also throw out in the list of things that you've given a shout out to, I would point out PyScript as well.
Oh yes, of course. Yeah, I just started managing the PyScript team again, actually, and so yeah, I forgot about that one too. Yes, PyScript. So Python in your web browser, Python everywhere, on your phone, in your browser, all the places.
Yeah, I mean it's a little bit out of left field compared to the other things that you all are working on, but
hmm
it's also a super important piece, I think. So
Yep.
yeah, really cool there.
hmm
So I think we set the stage a bit, but maybe let's start with Numba.
hmm
That one's been around for a while. Some people know about it, others don't. What is Numba and how do we make Python code faster with Numba?
Yeah, so there've been a lot of Python compilation projects over the years. Again, Numba's very fortunate that it's now 12 years old, so we've been doing it a long time, and I've been involved with it probably almost 10 of those years now. And Python, I think one of Numba's success points is trying to stay focused on an area where we can have a big impact, and that is trying to speed up numerical code. So there's a lot of, again, in data science and other sciences, there's a lot of need to write custom algorithms that do math. And Numba's sweet spot is really helping you to speed those up. So we see Numba used in a lot of places where maybe the algorithm you're looking for isn't already in NumPy or already in JAX or something like that. You need to do something new. Projects like UMAP, which do really novel sort of clustering algorithms, or I just at SciPy learned more about a project called Stumpy, which is for time series analysis.
Okay.
Those authors were able to use Numba to take the numerical core of that project, that was the sort of the time bottleneck, and speed it up without having to leave Python. And so that is, I think, really where Numba's most effective.
Sure. If you look at a lot of programs, there might be 5,000 lines of code or more, but even just something only as big as 5,000 lines. There's there's a lot of code, but only a little bit of it really actually matters, right?
hmm Yeah, that's what we find a lot is when you sit down and measure your code, you'll spot some hotspots where 60 or 70 or 80% of your time is spent in just like three functions or something, and that's great. And if that's the case, that's great because you can just zero in on that section for speeding things up and not ruin the readability of the rest of your program. Sometimes optimization can make it harder to read the result, and so there's always a balance of, you have to keep maintaining this project. You don't want to make it unreadable just to get 5% more speed or
Yeah,
something like that.
absolutely. Yeah, absolutely. Not just the readability, but the ability to evolve it over time,
Hmm.
right? So maybe it's like, oh, we're gonna compile this section here using Numba or Python or something like that. Well, maybe I was gonna use this cool new PyPI package I found, but
Hmm.
I can't just jam it in there where it's compiled. That's unlikely to work well,
Hmm.
right? And things like that. And so, yeah, a lot of times there's these big sections that look complicated, they look slow, they're not actually.
Yeah. And one thing I also often emphasize for people is that when you think about the time your program takes, think about the time you spent working on it as well as the time you spent running it. And so,
Yeah.
because we've heard from a lot of projects who said they were able to get major speed ups, not because necessarily because Numba compiled their code to be, incredibly fast, but it compiled it to be fast enough that they could try new ideas quicker. And so they got to the real win, which was a better way to solve their problem because they weren't kind of mired in just kind of boilerplate coding for
Right,
so
right,
long.
right, right. I it turns out I learned I should use a dictionary and not a list, and now it's 100 times faster. And that wasn't
Yes.
actually a compiling thing, that was a visibility thing or something, right?
Yeah, try more things is always helpful, and so a tool that lets you do that is really valuable.
100%. So, what tools do you recommend for knowing? Because our human intuition sometimes is good, but
Hmm.
sometimes is really off the mark in terms of thinking about what parts are slow, what parts are fast.
Yeah, that's something definitely when I've talked to people, everyone thinks they know where the slow part is, but sometimes they're surprised. And so you definitely before you do anything, this is not just Numba advice. This is anytime before you're going to speed up your program, measure something. So what you want is you want a representative benchmark, something that's not going to run too fast because often like unit tests run too quickly to really tell you to exercise the program in a realistic way. So you want a benchmark that doesn't run too long, but maybe like 5 minutes or something. And then you're going to want to run that through a profiling tool. And there are several options. I just usually tell people to use cProfile. It's built into the standard library in Python. It's a great tool. It does the job for most stuff. And so sometimes there are other tools, things like SnakeViz and other things that help you interpret the result of the profile, but often you'll use
Yeah.
cProfile to collect the data. And what this does is it samples, it sort of records as the program is running, what are all the functions that are being called and how much and how much time are they taking. And there are different strategies for how to do this, but fundamentally what you get out is essentially a data set that says 2% of the time in your program this function was running and 3% this function was running, and you can just sort that in descending order and look and see what pops out at the top. And sometimes you're surprised. Sometimes you find out it wasn't my numerical code, it's that I spent 80% of my time doing some string operation that I didn't realize I needed to do over and over again.
Right, exactly. Some weird plus equals with a string was just creating
Yeah.
1,000 strings to get to the endpoint or something like that. Yeah.
Yeah, and I could have just done that once up front. So it's good to do the profiling just to make sure there isn't an obvious problem before you get into the more detailed optimization.
Yeah. Before you start changing your code completely, its execution method or whatever.
Yep.
Yeah. And shout out to the PyCharm folks. They've got to push the button to profile and they've got to visualize it, and it just runs cProfile right in there. So that's like
Beautiful.
cProfile on easy mode. You get a spreadsheet and you get a graph. What about other ones like FIL, or anything?
Yeah.
Else?
So
Any other recommendations?
So that's an interesting point. Is the cProfile is for compute time profiling. An interesting problem you run into is what this tool does, which is memory profiling, which is often a problem when you're scaling up. And that's actually one of the other good things to keep in mind when you're optimizing is, what am I trying to do? Am I trying to get done faster? Am I trying to save on compute costs? Am I trying to go bigger? And so I have to speed things up so that I have room to put more data in. If that's where you're going, you might.
Or am I just out of memory?
Yeah,
right?
Am I already stuck? And so there it is very easy in Python to not recognize when you have temporary arrays and things. Because again, it's also very compact and you're not seeing what's getting allocated. You can accidentally blow up your memory quite a lot. And so this kind of a profiler is a great option for it. What it can often show you is they'll kind of a line by line. This is how much memory was allocated in each line of your program. So you can see, oh, that one line
Yeah.
of pandas, oops, that did it.
Yeah, I can't remember all the details. I talked to Itmar about this one, but I feel like it also keeps track of the memory used, even down into like NumPy and below, right? Not just Python memory, where it says now
Yeah.
there's some opaque blob of data science stuff.
Yeah, and actually, even on the compute profiling, there's sort of two approaches. So C profile is focused on counting function time, but sometimes you have a long function, and if you're making a bunch of NumPy calls, you might actually care line by line how much time is being taken, and that could be a better way to think about it. And so I think the tool is called LineProf.
Yeah.
I forget
Okay.
the exact URL, but it's an excellent tool in Python for. There's one in R, and there's an equivalent one. Yes,
Line profile.
Line profiler. There you go.
It's archived.
Oh, it's archived. Okay.
Yeah.
I have to find another tool now. This is my go-to for so long. I didn't realize it had already been archived. Oh, there's a current.
Hey, if it still works, it's all good. It's all good.
Yeah, it's been transferred to a new location, so that's where it lives now. But yeah, line profiling is another. I often use them complementary sort of tools. Is I zero in on one function with C profile, and then I'll go line profile that function.
Oh, interesting.
Drill in further.
Yeah, okay, this is the general area. Now let's really focus on it.
Yeah.
Memory is another one. I talked to the folks from Bloomberg about that.
Oh, that's okay. I have not used this one.
Yeah, this is a pretty new one, and it's quite neat the way it works. This one actually tracks C and C++ and other aspects of allocations as well. So one of the problems you can run into with profiling is, especially memory profiling, I think, although if you just want to know about memory, but the more you monitor it, the more it becomes kind of a Heisenberg quantum mechanics type thing. Once you observe it, you change it. And so the answers you get by observing it are not actually what are happening. So you got to keep a little bit of an open mind towards that as well, right?
Yeah, and that's even a risk with the compute side of the profiling is you're using some compute time to actually observe the program, which means that it can, and these tools try to subtract out that bias, but it does impact things. And so you may want to have kind of a benchmark that you can run as your kind of real source of truth that you run without the profiler turned on, just to see a final runtime. Run with the profiler to break it down, and then when you're all done, you're going to want to run that program again with the profiler off to see if you've actually improved it wall clock time wise.
Yeah, absolutely. That's a really good point. It's just maybe do a % time it type of thing.
Yep.
So something along those lines. Okay. Anything else we want to talk about that? So let's okay. That was a little bit of a side deep dive into profiling, because before you apply some of these techniques like Numba and others, you certainly want to know where to apply it. And part of that is you might need to rewrite your code a little bit to make it more optimizable by Numba or these things. So first of all, what do you do to use Numba? Right? It's just you just put a decorator on there and
at the very simplest level, Numba's interface is supposed to be just one decorator. Now, there's some nuance, obviously, and other things you can do, but we tried to get it down to, for most people, it's just that. And the N in ngit means no Python, meaning we, get this code is not calling the Python interpreter anymore at all. It is purely machine code, no interpreter access.
Interesting. Okay, so some of these compiled, do a thing and compile your Python code to machine instructions. I feel like they still interact with PyObject pointers, and they still kind of work with the API of the Python data types.
Yeah,
which is nice, but it's a whole lot slower of an optimization than now. It's int32 and it's float32, and these are on registers.
Yeah, and this is part of the reason why Numba focuses on numerical code, is that NumPy arrays, and actually other arrays in PyTorch and other things that support the buffer protocol. So really, when Numba compiles this, it compiles sort of two functions. One is a wrapper that handles the transition from the interpreter into no Python land, as we call it. And then there's the core function that is kind of like you could have written in C or Fortran or something. And that wrapper is actually doing all the PyObject stuff. It's reaching in and saying, this integer, I'm going to pull out the actual number, and this NumPy array, I'm going to reach in and grab the data pointer and pass those down into the core where the actual all the math happens. And so the only time you interact with the interpreter is really at the edge. Then once you get in there, you try not to touch it ever again. Now, Numba does have a feature that we added some years ago called an object mode block, which lets you, in the middle of your NoPython code, go back and actually start talking to the interpreter again.
Maybe use a standard library feature or something. Yeah,
the most common use we've seen is you want a progress bar to update or something. That's not in your hot loop. You don't want to be going back to the interpreter in something that's really performance critical, but inside of a function you might have parts that are more and less. 1 out of a million iterations, I want to go update the progress bar or something. That's totally valid, and you can do that with Numba. There's a way to get back to the interpreter if you really need to.
Okay. Yeah, and it says it takes and translates Python functions to optimize machine code at runtime, which is cool. Mm-hmm. So that makes deploying it super easy, and you don't have to have compiled wheels for it and stuff. Using industry standard LLVM compilers, and then similar speeds to C is in Fortran.
Yeah,
which is awesome, but also has implications. If I can speak. Mm-hmm. For example, when I came to Python, I was blown away that I could just have integers as big as I want. If I keep adding to them, they just get bigger and bigger, billions, bazillions of bits of accuracy. And I came from C++ and C#, and where you explicitly said it's an int32, it's an int64, it's a double, and these all had ranges of valid numbers, and then you got weird wraparounds, and maybe you create an unsigned one so you can get a little bit bigger. I suspect that you may fall victim or be subjected to these types of limitations without realizing them in Python if you at ingit it, because you're back in that land, right? Or do you utilize magic to allow us?
We do not handle the big integer, which is what you're describing as sort of that integer that can grow without bound. Because our target audience is very familiar with NumPy looks at numbers sort of the way you described from C++ and other languages.
The D type and all that stuff, right?
Yeah, NumPy arrays always have a fixed size integer, and you get to pick what that is, but it has to be 8, 16, 32, 64. Some machines can handle bigger, but that it is fixed. And so once you've locked that in, you can't if you go too big, you'll just wrap around and overflow. And so so that limitation is definitely present again in Numba, but fortunately NumPy users are already familiar with thinking that way, so it isn't an additional constraint on them too much.
Right. Okay. And then one thing you said was that you should focus on using arrays.
Yes.
And that kind of data structures before you apply Numba JIT compilation to it. Does that mean list as in bracket, or are these NumPy type vector things? What? We all have different definitions of
yes, that's
what
true.
An array is.
Array. I would say generally, usually the go-to I talk to about is a NumPy array. So it has a shape. The nice thing, NumPy arrays can be multidimensional, so you can represent a lot of complex data that way. But within an array, there's a fixed element size. That element could be a record. So if you want for every cell in your array to store maybe a set of numbers or a pair of numbers, something, you can do that with custom D types and things, and Numba will understand that. But that's the ideal data structure. Numba does have, we added support a couple years ago for other data structures, because the downside to a NumPy array is that it's fixed size. Once you make it, you can't append to it like you can a Python list. So Numba does have support for both what we call typed lists and typed dictionaries. So these are sort of special cases of lists and dictionaries in Python, where in the case of a list, every element in the list has the same type, or in the case of a dictionary, the keys are all the same type and the values are all the same type. Right. And those cover a lot of the cases where, again, used in when users want to make things where they don't know how long it's going to be, you're going to append in the algorithm. A list is a much more natural thing than a NumPy array, where you might over allocate or something. That seems and dictionaries. Sure. Our dictionary implementation is basically taken straight from CPython's dictionary implementation. So it's very tuned and very fast in the same way CPython's is. We just had to modify it a little bit to add this type information, but it's really good for kind of lookup random items kind of stuff. So those are available as additional data structures in addition to the array.
Yeah, and to use those, I would say from Numba import something like this.
Mm-hmm. Yeah, they're a new type in the docs. They'll show you can sort of import a typed list as a special class that you can create. The downside, by the way, is that and the reason we have those and we don't just take, historically Numba used to try and let you pass in a Python list, is that wrapper function would have to go recursively through the list of whatever you might have and pop out all of the elements into some format that wasn't all Py objects, so that the NoPython code could manipulate them quickly. And then how do you put it all back if you modify that sort of shadow data structure? And so what we realized is that was confusing people and actually added a lot of overhead, and calling functions took too long. So we instead went up a level and said, okay, we're going to make a new kind of list that you at the interpreter level can opt into for your algorithm. And so accessing that list from Python is slower than a Python list, but accessing it from Numba is like 100 times faster. So you kind of have to decide while I'm in this mode, I'm optimizing for Numba's performance, not for the Python interpreter performance.
Which is reasonable, often I'd imagine, because this is the part you found to be slow.
Yeah, that's the trade-off you make. And so we would not suggest people use type lists just in random places in their program.
Right. I heard really this is fast, so we're just going to replace all, like, new rule. Bracket is disallowed. We're now using this one, right?
Yeah. When you're working with Python objects, Python's data structures can't be beat. They are so well tuned that it's very, very hard to imagine something that could be faster than them.
All right. So maybe one more thing on Numba we could talk about is so far, I imagine people have been in their mind thinking of, I have at least, running on CPUs, be that on Apple Silicon or Intel chips or AMD or whatever. But there's also support for graphics cards, right?
Yes. Yeah. So for a very long, I mean, we've had this again for 10 plus years. We were very early adopters of CUDA, which is the programming interface for NVIDIA GPUs. CUDA is supported by every NVIDIA GPU, whether it's a low-end gamer card or a super high-end data center card. They all support CUDA. So that was really nice for people who were trying to get into GPU programming. You could use inexpensive hardware to learn. And so on both Windows and Linux, Macs don't have NVIDIA GPUs for a long, long time now. But on Windows and Linux, you can basically write what they call a CUDA kernel in pure Python. And it just, you can pass up, arrays, either NumPy arrays, which then have to be sent to the card, or special GPU arrays that are already on the card. And so that is a great way for people to learn a bit more about GPU programming. I will say Numba might not be the best place to start with GPU programming in Python, because there's a great project called CuPy, C-U-P-Y, that is literally a copy of NumPy, but does all of the computation on the GPU. And CuPy works great with Numba. So I often tell people, if you're curious, start with CuPy, use some of those NumPy functions to get a sense of, when is an array big enough to matter on the GPU, that sort of thing. And then when you start wanting to do more custom algorithms, Numba is where you kind of turn to for that second level. Yeah.
So I feel like I'm referencing a lot of Itamar's work over here, but what if we didn't have a NVIDIA GPU? Is there anything we could do?
Yeah, so there are other projects. So things like, as I mentioned here, like PyTorch and things have been ported to a number of different backends. Well, this is one thing the Numba team we are frequently talking about, is how do we add non-GPU or non-NVIDIA GPU support? But it's I don't have an ETA on that. That's something that we just still are thinking about. But PyTorch definitely, and you can use PyTorch as an array library. You don't have to be doing machine learning necessarily. You can use it just
interesting.
Fast arrays. It's just most popular because it supports, JAX is a very similar thing, because it adds the extra features you want for those machine learning models. But at the core of every machine learning model is just array math. And so you could choose to just do that if that's what you want. And then you could even still pass those arrays off to Numba at some point in the future. Because we all
Yeah, I didn't realize there was
understand each other's
integration.
protocols.
Yeah, I didn't realize there was integration with that as well. That's super
Yeah,
cool.
a while back, we kind of worked with a number of projects to define a GPU array interface that's used by a number of them, so that we can see each other's arrays without having to copy the data, which is very helpful.
Yeah, yeah. We have a lot more topics other than Numba, but I'm still fascinated with it.
Yeah.
So,
Oh yeah,
so one of the big, all the rage now is vector databases, obviously,
Mhm.
because I want to query my way through LLM outputs, right?
Mhm.
Like, where in 100,000 dimensional space does this question live?
Yep.
Or whatever. Is there any integration with that kind of stuff back into Numba?
Numba not directly, although Numba does have interfaces. An easy way to call out to C functions. So a lot of these vector databases are implemented in C or C++ or something. And so if you did have a use case where you needed to call out to one of them, if there was a C function call to make directly to sort of the underlying library that bypassed the interpreter, you can do that from Numba. And so I haven't seen anyone do that yet, but it's a generic sort of C interface.
Yeah, well, maybe there's a database driver written in C, in which case, I don't know all the different databases. I know there are some that are specifically built for it. Maybe DuckDB's got something going on here, but also MongoDB has added vector stuff to it, and I know they have a C library as well.
Yeah, so, I've looked at LanceDB is one I've seen mentioned used by a couple of projects that's just for vector.
Which one is it called?
Do anything else? LanceDB.
LanceDB. Okay.
Yeah, I heard about it in the context of another Python LLM project.
Sure. Okay.
So
cool. Well, that's news to me, but it is a developer-friendly open source database for AI. Okay. Brilliant. All right. Well, like I said, we have more things to talk about.
So many things.
So many things, but this is super. Okay. One more thing I want to ask you about here before we go on.
Yeah.
This has a Cython feel to it. Can you compare and contrast Numba to Cython?
Yeah, so Cython uses sort of requires you to put in some type information in order to be able to generate C code that is more efficient. Numba is mainly focused on type inference. So we try to figure out all the types in your function based on the types of the inputs. And so in general, although Numba has places where you can put type annotations, we generally discourage people from doing it because we find that it adds work and is error prone and doesn't really help the performance in the end. Numba will figure out all the types directly. And so
when it JIT compiles it, if it comes in, if you call it twice with different types, does it just say, well, now we're going to need this version of the function _ strings list rather than integers list or something?
Yeah. Every Numba compiled function actually contains a dispatcher that will look at the argument types and pick the right one. And it's at pretty high granularity. For example, people who are familiar with multidimensional arrays in like Fortran and C know that they lay out the rows and columns in a different order, which has impact on how you do loops and stuff for kind of to maximize locality. Numba can tell the difference between those two cases and will generate different code for those two cases.
Wow.
So
you're thinking about
you as the user don't want to even know.
No, you don't want to worry about that. That's a whole nother level. So you were like, okay, well, if it's laid out in this order, it's probably this. It appears on the the local cache for the CPU in this way. And so if we loop in that direction, we'll like iterate through the cache instead of blow through it every loop or something.
Yeah, we want to make sure that LLVM knows when the step size is 1, and that's either on the row or the column axis, depending on that. And because I mean, compilers in general are magic. Like, we are grateful that LLVM exists because they can do so many tricks at that level. This is the same thing that powers Clang and other stuff. So all of Mac OS compilers are built on LLVM, and so we can leverage all of the tricks they've figured out in decades of development.
Yeah, that's cool. And Python itself is compiled with that, at least on Mac OS. Yep. I just saw it last night. That I have Clang some version, whatever. When I was just looking at the version for my Python, it was compiled with that. Cool. Okay, so what is next? Let's talk about. We've been on the Numba JIT.
Yep.
Anthony Shaw wrote an article, Python 3.13 gets a JIT, and this is a pretty comprehensive and interesting article on what's going on here. What's your experience with this JIT coming to Python 3.13?
Yeah, this is and they've definitely tried to set expectations here that this first release is really planting a flag, is to
Yeah.
say we're going to start building on top of this base. And so as far as I've seen, the benchmarks for 3.13 are not going to be light the world on fire kind of stuff.
See, we're not throwing away our C code and rewriting operating
Yeah.
systems and JITted Python.
But you have to take a first step, and this is honestly pretty this is it always impressed me because Numba as a library, we can take a lot of risks and do things that I know we can depend on LLVM. We can do all sorts of stuff that maybe not work for everyone, because if Numba doesn't solve your problem, you just don't use it. You can just leave it out of your environment. You don't have to install it. And so it's easy to kind of us to zero in on just the problems that we're good at and say, if this doesn't solve your problem, just leave us out. When you actually are putting a JIT into the core interpreter, everyone gets it. And you have to consider, and Python is so broad that you could grab two Python experts, and they may actually have nothing in common with each other.
Yeah.
And they but are both equal claim to being experts at using Python, but they might use them in different domains and have different libraries they care about and all of that.
I feel that way when I talk to Pandas people.
Mhm.
And I think about me doing like web development APIs and stuff. I'm
Yep.
like, I think I'm really good at Python generally, good enough to write good apps. But then I look at this, I'm like, I don't even really some of these like expressions that go into the filter brackets. I'm like, I didn't even know that was possible or really how to apply, like it's weird to both feel really competent and understand it, but also have it kind of no idea. And what I think what you're getting at is those are two really different use cases, and they're getting the same JIT, and it has to work for both of them. But
Yes.
combinatorially explode that problem, right?
Yeah, and all the different hardware. I mean, Numba supports a lot of different computers, but not everyone that Python supports. We don't
like micro Python.
Yeah, or we don't work on HPUX or anything like that necessarily. So Python has an enormous range of supported platforms, an enormous set of use cases, and anything you do is going to affect everyone. And so this approach, which I would say this copy and patch JIT approach, is really clever. Because one of the, again, Numba has to bring, we build a, custom version of LLVM. It's a little stripped down, but it's mostly still there. So we have to bring that along for the ride. That's a heavy, heavy dependency to put on the core interpreter for everyone. So the clever bit here is they figured out how to have a JIT, but still do all the compiler stuff at build time. So when you build this copy and patch JIT, you actually need LLVM, but only at build time. And then it can go away. And so the person who receives the interpreter doesn't need LLVM anymore.
Wow.
So
Okay.
they've basically built for themselves a bunch of little template fragments. This is the patching part, is basically you're saying, I've got a bunch of fragments that implement different opcodes in the bytecode different ways. And I'm going to string them together and then go in, and there's a bunch of fill in the blank spots that I can go in and swap in you get your value from here and then you put it over here and all that. But the actual machine code was generated by LLVM by the person who built Python in the first place. And
I see.
It just amazes me this works, and I'm excited to see where they go with it. Because it was a clever way to avoid adding a huge heavy dependency to Python, but start to get some of that JIT benefit.
So it looks at some of the common patterns.
Mhm.
I see. Okay, we're looping over a list of floats or something, and replaces that with more native code or something along those lines.
Yeah. You essentially have a compiler print a bunch of little recipes that are, if I do this pattern, sub in this machine code, fill in these blanks, and you just have a table of them. So it's the challenge there is that there is a combinatorial explosion again of how many different, a full blown compiler like LLVM has a bunch of rules. It's rule based. And so it's saying, if I see this pattern, I do this replacement, and it keeps doing all of this. And then at the end, it says, okay, now I'm going to generate my machine code from those transformations. If I don't have LLVM at runtime, I have to kind of figure out what are the best templates up front, put them in this table, and then, and so this is where honestly, looking at different usage patterns will probably be a huge help. Is in practice, you could have any sequence of bytecodes, but in reality, you're probably going to have certain ones a lot, and those are the
Right.
ones you want to focus on. So I think once I don't know, once we start getting this out in the community and start getting feedback on it, I'm curious to see how rapidly it can evolve. That'll be really
Sure.
interesting.
Yeah, and this whole copy and patch it JIT is, you know, we often hear people say, I have a computer science degree. And I think what that really means is I have a software engineering degree or I am a software engineering person. They are not
Mhm.
often creating new science, computer science of theories. They're more like, I really understand how operating system works and programmers and compilers. And I write, JSON APIs, or I talk to databases.
Mhm,
But
mhm.
this is like true new research out of legitimate computer science, right? This
Yeah, I
copy
mean,
and paste JIT.
they mentioned. I mean, they cite a paper from 2021, and
Yeah,
in computer science,
exactly.
going from paper to implementation in one of the most popular languages on earth in 3 years seems pretty fast.
It does seem pretty fast, right? It definitely seems pretty fast. And the reason I bring this up is I imagine that dropping it into one of the most popular programming languages with a super diverse set of architectures and use cases will probably push that science forward.
Yep. Yeah. This will be tested in one of the most intense environments you could imagine.
I mean,
So
whatever they did for their research paper or their dissertation or whatever, this is another level of putting it into tests and experimentation to put it into Python.
yep.
Yeah, wild. Okay. Hopefully this speeds things up. This is going to be interesting because it just happens, right? It just happens. If you have Python 3.13, it's going to be looking at its patterns and possibly swapping out
Hmm.
JIT,
And this is
these recipes.
yeah, and this is complementary to all of the techniques the faster C Python folks have been doing all along for many releases now.
Yeah,
Is they've been looking at other ways to speed up the interpreter without going all the way to a full blown compiler, which this is kind of
sure.
getting you the final step. So that's again another interesting place is how does this complement those? I don't know those details, but it's another tool in the toolbox to sort of go back to the beginning. It's speed is about having a bunch of tools, and you kind of pick up 5% here and 5% there,
Mhm.
and you pile up enough 5%, and pretty soon you have something substantial.
Yeah, I absolutely. That was the plan, right? The faster C Python was to make it multiples of times faster by adding, 20% improvements release over release over release and,
Yep.
compounding in percentages basically.
Hmm.
The one thing I don't know about this is we've had this specializing adaptive interpreter that was one of those faster C Python things that came along.
Hmm.
Is this just the next level of that, or is this a replacement for that? I don't know. I'm sure people can.
Yeah, I
us
don't
know.
know. I don't know what their roadmap is for that, because I think part of this is so new. I think they got to see how it works in practice
Right.
before
It
they start figuring out.
feels.
Yeah.
I agree. It feels like an alternative to that specialized and adaptive interpreter, but I don't know. Maybe some of the stuff they've learned from one made it possible, or
Mhm.
even is just an extension of it.
Yeah.
Okay. What did we want to talk about next here? I think
You want to talk about threads?
no. Let's talk. I want to talk
Go.
about Rust really quick before we talk
Okay.
about then
Mhm.
because that'll be quick, and then I want to talk about threads because threads will not be as quick, and it's super interesting. It's been a problem that people have been chipping at for years and years and years. The threads thing, but
Mhm.
what do you think about all this Rust mania? I mean, it's shown some real positive results, things like
Mhm.
Rough and Pydantic and others, but it's
Mhm.
actually a little bizarrely controversial, or maybe not bizarre, non-obviously controversial.
Yeah, I mean, my take on the Rust stuff is I view it in the same light as when we use C and Fortran historically. It's just Rust is a nicer language in many ways,
Yeah,
and so if being a nicer language means certainly, you could have taken any of these things and rewritten them in C a long time ago, and they would have been faster. You just didn't want to write that C code. That was
exactly.
and so
You know what? We could
Rust,
do this in assembler, and it would fly, guys.
yeah, and so Rust is moving things. Rust lowering the bar to saying, okay, maybe I'll implement the core of my algorithm outside of Python entirely, is interesting. And honestly, I would happily see Rust completely replace C as the dominant extension language in Python.
Yeah.
The trade-off here, and this is one of those things that's sometimes easy to forget, again, because the Python community is so diverse, is when you do switch something to Rust, you do reduce the audience who can contribute effectively in some cases.
Yeah.
That Python using Python to implement things has a benefit for the maintainers if it lets them get more contributions, more easily onboard new people. We hear this. I hear this a lot actually from academic software, where you have this constant rotating, students and postdocs and things. And so how quickly you can onboard someone who isn't a professional software developer into a project to contribute to it is relevant. And so, but I think it's different for every project. There are some things like, again, Rust in cryptography makes total sense to me because that's also a very security conscious thing. You really don't want to be dealing with C buffer overflows in that kind of code. And so the guarantees Rust offers are valuable also.
Well, and I think that's also makes sense even outside of just security directly. If you're going to build a web server, it's a nerve-wracking thing to run other people's code on an open port on the internet. And so this is better. One of the things I switched to is I recently switched to Granian. For a lot of my websites, which is a Rust HTTP server. It's comparable in performance, slightly faster than other things, but it's way more. Its deviation from its average is way better.
So it's just more consistent.
More consistent, but also, like the average, for example, where's the versus third-party server? That's the one I want. So against MicroWhiskey, for example, right? It's 6 milliseconds versus 17 milliseconds. Like, whatever. But then you look at the max latency is 60 versus 3 seconds. It's like, oh,
wow,
hold on. Right. Yes. But the fact it's written in Rust, I think feels it's a little bit of extra safety, all other things being equal. Right. And that I mean, obviously a lot of caveats there. But.
Yeah. The interesting point about, and this is not unique to Rust, this is again the same problem with C and other things, is that it's a little bit interesting. On one hand, we're pushing the Python interpreter and JITs and all this other stuff at the same time as you're thinking about whether to pull code entirely out of Python. And it creates a barrier where the JIT can't see what's in the Rust code. And so if there was an optimization that could have crossed that boundary, it's no longer available to the compilers. This is a problem the Numba team has been thinking about a lot, because our number one request, aside from other GPUs, is can Numba be an ahead of time compiler instead of a just in time compiler? And we were like, superficially, yes, that's straightforward. But then we started thinking about the user experience and the developer experience, and there are some things that you lose when you go ahead of time that you have with the JIT, and how do you bridge that gap?
And so it gets tricky.
We've been trying to figure out some tooling to try and bridge that. So at SciPy, we did a talk on a project we just started called Pixie, which is a sub-project of Numba that is trying to, which doesn't have Rust support yet, but that's been one of the requests. So if you go to github.com/numba/Pixie,
search engines. Search engines are pure magic. They really are.
Awesome. Well, you found our issue tracker. But there we go. But Pixie, we gave a talk about it at SciPy. It's very early stages, but what we're trying to do is figure out how to, in the ahead of time compilation, whether that's C or Rust or even Numba eventually, capturing enough info that we can feed that back into a future JIT, so that the JIT can still see what's going on in the compiled code, as kind of a future-proofing the ecosystem.
Yeah, that's cool. I know some compilers have profiling-based optimization type things. Like you can compile it with some instrumentation, run it, and then take that output and feed it back into it. And I don't know if I've ever practically done anything with that, but I'm like, oh, that's kind of a neat idea to try it, let it see what it does, and then feed it back. Is this sort of like that, or what do you think?
Yeah, this is different. This is sort of This is basically capturing in the library file. So you compiled ahead of time to a library, capturing the LLVM bitcode so that you could pull it out and embed it into your JIT, which might be have other LLVM bitcodes. So then you can optimize. You could have a function you wrote in Python that calls a function in C, and you could actually optimize them together, even though they were compiled at different times, implemented in different languages. You could actually cross that boundary.
One's like a ahead of time compilation, just standard compilation, and one is like a JIT thing, but it's like, oh, we're going to click it together in the right way. Wild.
Yeah, because JITs are nice in that they can see everything that's going on, but then they have to compile everything that's going on, and that adds time and latency and things. And so, can you have it both ways? That's really what we're trying to do.
It's nice when you can't have your cake and eat it too, right?
Yes.
Have my cake before my vegetables, and it'd be fine. I said that this Rust thing was a little bit controversial. I think there's some just, hey, you're stepping on my square of Python space with a new tool, and I don't think that has anything to do with a Rust per se. It's just somebody came along and made a tool that is now doing something maybe in better ways, or I don't know. I don't want to start up a whole debate about that. But I think the other one is what you touched on is, if we go and write a significant chunk of this stuff in this new language, regardless what language it is, Rust is a relatively not popular language compared to others, then people who contribute to that, either from the Python side, we're like, well, there's this big chunk of Rust code now that I don't understand anything about, so I can't contribute to that part of it. And you might even say, well, what about the pro developers or the experienced core developers and stuff? They're experienced and pro at C and Python, which is also not Rust, right? Like it's this new area that is more opaque to most of the community, which I think that's part of the challenge.
Yeah, that's do you? Some people like learning new programming languages, and some don't, and it. So on some hand, Rust can be this is a new intellectual challenge, and it fixes practically some problems you have with C. Or in other cases, it's I wanted to worry about what this project does and not another programming language.
Right.
And kind of have to look at your communities and decide what's the right trade-off for you.
Maybe in 10 years, C Python will be R Python, and it'll be written in Rust. I mean, that's if we move to WebAssembly and like PyScript, Pyodide land a lot, like having that right in there's a non-zero probability, but it's not a high number, I suppose. Speaking of something I also thought was going to have a very near zero probability.
Yeah.
PEP 703 is accepted. Oh my goodness. What is this?
Yeah. So this was, again, a couple of years ago now, or I guess a year ago, it was finally accepted. So this is, since very long time, the Python interpreter has, because, again, threads are an operating system feature that let you do something in a program concurrently. And now that all of our computers have 4, 8, even more cores, depending on what kind of machine you have. Even your cell phone has more than one core. The using those cores requires you have some kind of parallel computing in your program, and so the problem is that you don't want once you start doing things in parallel, you have the potential for race conditions. You have the two threads might do the same thing at the same time or touch the same data, get it inconsistent, and then your whole program starts to crash and other bad things happen. So historically, the global interpreter lock has been the sort of sledgehammer protection of the CPython interpreter. But the net result was that threads that were running pure Python code basically got no performance benefits. You might get other benefits, like you could have one block on I/O while the other one does stuff, and so it was easier to manage that kind of concurrency. But if you were trying to do compute on 2 cores at the same time in pure Python code, it was just not going to happen, because every operation touches a Python object has to lock the interpreter while you make that modification.
You could write all the multi-threaded code with locks and stuff you want, but it's really just going to run one at a time anyway.
Yeah,
a little bit like preemptive multi-threading on a single core CPU, or I don't know, it's some weird, like I've added all this complexity, but I haven't got much out of it.
The secret, of course, is that if your Python program contained not Python, like C or Python or Fortran, as long as you weren't touching Python objects directly, you could release the GIL. And so, Python, so especially in the scientific and data computing and data science space, multi-threaded code has been around for a long time, and we've been using it, and it's fine. Dask, you can use workers with threads or processes or both. And so I frequently will use Dask with 4 threads, and that's totally fine because most of the code's in NumPy and Pandas that release the GIL. But that's only a few use cases. And so if you want to expand that to the whole Python interpreter, you have to get rid of the GIL. You have to have a more fine-grained approach to concurrency. And so this proposal from Sam Gross at Meta was basically one of many historical attempts to kind of get rid of that global interpreter lock. Many have been proposed and failed historically. So getting this all the way through the approval process is a real triumph. At the point where it was really being hotly contested, my maybe slightly cynical take is we have between 0 and 1 more chance to get this right in Python. Either it's already too late or this is it. And I don't know which it is.
I think there were 2 main complaints against this change. Complaint number 1 was, okay, you theoretically have opened up a parallel compute thing. So for example, on my Apple M2 Pro, I have 10 cores. So I could leverage all of those cores, maybe get a 5 times improvement. But single core regular programming is now 50% slower. And that's what most people do, and we don't accept it, right? That's the one of the sides, the galectomy and all that was kind of in that realm, I believe. The other is yet to be determined, I think, is much like the Python 2 to 3 shift. The problem with Python 2 to 3 wasn't that the code of Python changed. It was that all the libraries I like and need don't work here, right? And so what is going to happen when we take 500,000 libraries that were written in a world that didn't know or care about threading and are now subjected to it?
Yeah, and there's sort of 2 levels of problem there. There's one that there's work that has to be done to libraries. It's usually with C extensions that didn't assume that they assumed a global interpreter lock, and they'll have to do some changes to change that. But the other one is a much more cultural thing, where the existence of the GIL just meant that Python developers just wrote less threaded code. And so
they don't think about locks. They don't worry about locks. They just assume it's all going to be fine.
And so you can, because again, the race condition doesn't protect threaded code from the GIL doesn't protect threaded code from race conditions, but it just protects the interpreter from race conditions. So you, in your application logic, are free to make all the thread mistakes you want. But if no one ever ran your code in multiple threads, you would never know. And so we're going to have to face that now.
I think that's a super interesting thing, that it's a huge cultural issue that just people don't think about it. Like I said, I used to do a lot of C++ and C#, and over there, you're always thinking about threading. You're always thinking about, well, what about these 3 steps? Does it go into a temporarily invalid state? Do I need to lock this? Right? And like C# even had literally a keyword lock, which is like a context manager. You say lock curly brace, and everything in there is like into a lock and out of, like, because it's just so part of that culture. And then in Python, you kind of just forget about it and don't worry about it. But that doesn't mean that you aren't taking multiple, like 5 lines of Python code. Each one can run all on its own, but taken as a block, they may still get into these like weird states where if another thread after 3 lines observes the data, it's still busted, right? It's just the culture doesn't talk about it very much.
Yeah, if no one ever runs your code in multiple threads, all of those bugs are theoretical. And so it's now what's going to shift is all of those C extensions will get fixed, and everything will be, they'll fix those problems. And then we're gonna have a second wave of everyone seeing their libraries used in threaded programs and starting to discover, what are the more subtle bugs? Do I have global state that I'm not being careful with? And it's going to be painful, but I think it's necessary for Python to stay relevant into the future. I'm a little worried. I mean, one of the common questions we hear is sort of, why multiprocessing is fine? Why don't we do that? And definitely multiprocessing's big challenge is processes don't get to share data directly. So either even if I have like read-only data, I might, if I have to load 2 gigabytes of data in every process, and I want to start 32 of them because I have a nice big computer, I've just 32x'd my data, my memory usage, just so that I can, have multiple concurrent computations. Now there are tricks you can play on things like Linux where you load the data once and then rely on forking to preserve pages of memory. Linux does cool copy on write stuff when you fork.
Yeah.
But that's like fragile and not necessarily going to work. And then the second thing, of course, is if any of those have to talk to each other, now you're talking about pickling objects and putting them through a socket and handing them off. And that is, again, for certain kinds of applications, just a non-starter. And
yeah, but then people will just start going, well, we're just going to rewrite this in a language that lets us share pointers.
Yeah.
Or at least memory in process. Yeah.
Yeah. There are a lot of Python users where they don't need this. They don't care about this. This will never impact them. And then there's a whole class of Python users who are desperate for this.
Sure.
And really want it.
I think there's a couple interesting things here. One, I think this is important for stemming people leaving Python. I actually don't hear this that much anymore, but I used to hear a lot of, we've left for Go because we need better parallelism, or we've left for this performance reason. And I don't know that's just a success story of the faster CPython initiative, or all the people who had been around and decided they needed to leave, they're gone, and we just don't hear them anymore because they left. It's like, I used to hear them say this at the party, but then they said they're going to leave, and I don't hear anyone say they're leaving. Well, it's because everyone's still here didn't say that. I don't know, but I do think having this as a capability will be important for people to be able to maybe adopt Python where Python was rejected at the proposal stage. Like, should we use Python for this project or something else? Oh, we need threading. We need computational threading. We've got, 128 core. It's out. Right. And then no one comes and complains about it because they never even started that process. Right. So it'll either allow more people to come into Python or prevent them for leaving for that same argument on some projects. So I think that's a pretty positive thing here.
Yeah, we don't get to count all of the projects that didn't come into existence because of the global interpreter lock. It's easy when you're in it to sort of adjust your thinking to not see the limitation anymore because you're so used to routing around it. You don't even stop and think, oh man, I got to worry about threads. You just don't think threads.
Yeah, I totally agree. And I'll give people two other examples that maybe resonate more if this doesn't resonate with them. What if I said, it's a little bit challenging to write this type of mobile phone application in Python. It's like, well, it's nearly impossible to write a mobile phone application in Python. So we're not even focusing on that as an issue because no one is, I know, Beware and a few other things. There's a little bit of work. So I don't want to I'm not trying to talk bad about them. But as a community, there's not it's not a React Native sort of thing or a Flutter where there's a huge community of people who are just like, and we could do this. And then how do we, there's just not a lot of talk about it. And that doesn't mean that people wouldn't just love to write mobile apps in Python. It's so far out of reach that it's just a little whisper in the corner for people trying to explore that rather than a big din. And I think, same thing about desktop apps, right? Wouldn't it be awesome if we could not have Electron, but some really cool, super nice UI thing that's almost pure Python? It would, but people were not focused on it because no one's trying to do it, but no one's trying to do it because there weren't good options to do it with, right? And I think the same story is going to happen around performance. I mean,
just to jump in, since I have to talk about the Beware folks. I mean, you've described exactly the reason why we fund the Beware development is because, if we don't work on that now before people sort of, there's a lot of work that has to do before you reach that point where it's easy. And so, recently the team was able to get sort of tier 3 support for iOS and Android into CPython 3.13. So now we're at the first rung of the ladder of iOS and Android support in CPython. And
that's awesome.
And Toga and Briefcase, the two components of Beware, are really focused again on that. How do I make apps? How do I make for desktop and mobile? And so, but it's we ran into people is that they just didn't even realize you could even think about doing that, and so they never stopped to say, "Oh, I wish I could do this in Python," because they just assumed you couldn't. And
and all the people who really needed to were required to leave the ecosystem and make another choice, right?
Yeah. And it will take the same amount of. I was going to say it takes the same amount of time with this. Even once threads are possible in Python, it'll take years to shift the perception.
Yeah, and probably some of the important libraries.
Yeah.
All right. So I'm pretty excited about this. I was hoping something like this would come, and I didn't know what form it would be. I said there were the two limitations: the libraries and the culture, which you called out very awesomely, and then also the performance. And this one is either neutral or a little bit better in terms of performance. So it doesn't have that disqualifying killing of the single threaded performance.
The approach they're taking here, I will say again, because you have to be fairly conservative with CPython because so many people use it, is that this will be an experimental option that by default Python won't turn this on. You will have Python 3.13 when you get it will still have the global interpreter lock. But if you build Python 3.13 yourself, or you get another kind of experimental build of it, there's a flag now at the build stage to turn off the GIL. So this is, in this mode, they decided to make, not have to make double negatives. This is Python in free threading mode. And that will be an experimental thing for the community to test, to try out, to benchmark, and do all these things for a number of years. They've taken a very measured approach, and they're saying we're not going to force the whole community to switch to this until it's proven itself out. Everyone's had time to port the major libraries, to try it out, to see that it really does meet the promise of not penalizing single-threaded stuff too much.
Yeah, or breaking single-threaded code too much, yeah.
Yeah, and so the steering council is reserving the right to decide when this becomes, or if this becomes the official way for Python. I don't know, 3.17 or something. I mean, it could be several years. And so I just want everyone not to panic.
Yeah, exactly.
This doesn't get turned on in October.
No, and this is super interesting. Yeah, so it's accepted, but it only appears in your Python runtime if you build it with this. So I imagine, some people will build it themselves, but someone will also just create a Docker container with Python built with this, and you can get the free-threaded Docker version or whatever, right?
We've already put out Conda packages as well. So if you want to build a Conda environment, actually, if you jump over to the Py free thread page.
Yeah, tell people about this.
Yeah, so we didn't make this. This is the community made this. The scientific Python community put this together, and this is a really great resource. Again, focused on that community which really wants threading, because we have a lot of heavy numerical computation, and so this is a good resource for things like how do you install it. So there's a link there on what are your options for installing the free threaded CPython. You can get it from Ubuntu or PyEnv or Conda. If you go look at the and you could build it from source. And so there's also
a container,
there's also a compatibility status tracker, which is being updated manually to see which of your again, this is focused I think down one more link.
Where's the there it is.
There it is. So these are, again, this is very focused on the kind of things the scientific Python community cares about, but these are things like, have we ported Cython? Have we ported NumPy? Is it being automatically tested? Which release has it? And the nice thing actually is pip, as of 24.1, I believe, can tell the difference between wheels for regular Python and free threaded Python.
So you can tell by there's different wheels as well.
Yeah. So that there's Python has always had this thing called an ABI tag, which is just a letter that you stick after the version number.
Yeah.
And T is the one for free threading. And so now a project can choose to upload wheels for both versions and make it easier for people to test out stuff. So, for example, Cython, it looks like there are nightly wheels already being built. And so this is, they're moving fast, and definitely, and at Conda, we're also very interested in getting into this as well. So that's why we built the Conda package for free threading, and we're going to start looking at building more Conda packages for these things in order to be able to facilitate testing. Because I think the biggest thing we want to make sure is, if you want to know if your code works, you want the quickest way to get an environment to have some place to test.
Yeah.
And so making this more accessible to folks is a really high priority.
This is cool. There was something like this for Python 2 to 3. I remember it showed like the top 1,000 packages on PyPI, and then how many of them were compatible with Python 3, basically by expressing their language tag or something like that.
Yep.
So this is kind of like that. It's also kind of like the can I use. I don't know if you're familiar.
Yes.
Can I use from the web dev world where you
go awesome. Yeah, I've seen this.
You go and say, I want to use this. I want to use this feature, and it'll, or if I want to say web workers or something like that, and it'll show you all the browsers and all the versions and when were they supported, and this sounds a little bit like that, but for free
Yep.
threaded Python. Which, by the way,
Yep.
free threaded Python is the terminology, right? Not no GIL, but free
Yes.
threaded.
That is what they've decided. I think they're worried about people trying to talk about no GIL, or I mean, I don't know.
Gilful,
Yeah,
Gilful
exactly.
Python. Are you running on Gilful? Oh my gosh. Okay, interesting. Now we have a few other things to talk about, but we don't have really much time to talk about them. But there was one thing that we were maybe going to talk about a bit, with compiling. You mentioned some talk or something where people were talking about, well, what if we had a static language Python and we compile
Yes.
it? And
Yeah.
related to that, kind of, Mr. Magnetic says, could a Python program be compiled into a binary like a jar or a Go app or whatever?
Yeah, there are other tools that look at that as a standalone executable. So yeah, one of the things I just wanted to shout out a colleague of mine at Anaconda, Antonio Cuny, who is a well-known PyPy developer from long ago. He's worked on PyPy for 20 years. He's been
and not the package installing thing, but the JIT compiler, PY. It's just, so sometimes phonetically, like over audio, that's hard to tell.
Yes, yeah. He's been thinking about this stuff for a very long time, and his sort of key insight that at least clicked in my head was that Python is hard to compile because it is so dynamic. I can, in principle, modify the attributes, like even the functions of a class at any point in the execution of the program. I can monkey patch anything. I can do this dynamicness is really great for making kind of magical metaprogramming libraries that do amazing things with very little typing, but it makes compiling them really hard because you don't get to ever say, okay, this can't ever change. And so what he's been trying to do with a project called Spy, which he gave a talk on at PyCon 2024, but I think the recordings aren't up yet for that. And so there isn't I don't think there's a public page on it, but he does have a talk on it. And because I think they've got like the keynotes up. But the key kind of insight for me for Spy was to recognize that in a typical Python program, all the dynamic metaprogramming happens at the beginning. You're doing things like data classes generating stuff and all kinds of things like that. And then there's a phase where that stops. And so if we could define a sort of variant of Python where those two phases were really clear, then you would get all of the dynamic expressiveness, almost all the dynamic expressiveness of Python, but still have the ability to then feed that into a compiler tool chain and get a binary. So this is super early R&D experimental work, but I think that's a really great way to approach it, because often there's always been this tension of, well, if I make Python statically compilable, is it just C with different keywords? Do I lose the thing I loved about Python, which was how quickly I could express my idea? And so this is again to our having your cake and eating it too. This is trying to find a way to split that difference in a way that lets us get most of the benefits of both sides.
That's pretty interesting, and hopefully that talks up soon. That would be really neat. Maybe by the time this episode's out, I know the PyCon videos are starting to roll, like not out on YouTube, but out on the podcast channels.
Yep.
It'll be interesting. It would be fantastic to have, here's my binary of Python. Take my data science app and run it. Take my desktop app and run it. I don't care what you have installed on your computer. I don't need you to set up Python 3.10 or higher on your machine and set up a virtual environment. Just here's my binary. Do it as you will. That's another, I throw that in with the mobile apps and the front end or the desktop apps or the front end Python. That's another one of those things that it's, nobody's pushing towards it. Or not that many people are pushing towards it because there's not that many use cases for it that people are using it for, because it was so challenging that people stopped trying to do that, Yeah,
there's one thing I also, people probably hear me say this too many times, but most people use apps when they use a computer, not packages or environments.
Yes.
And so
Yes.
in the Python space, we are constantly grappling with how hard packages and environments are to work with, talk with, decide again what languages are in, what, do I care about everything or just Python or whatever. That's all very hard, but that's actually not how most people interact with the computer at all. And so it really is one of those things. Again, this is one of the reasons I'm so interested in Beware. Is Briefcase is like the app packager, and the more they can push on that, the more we have a story. And again, there are other tools that have been around for a long time, but that's just one I think about a lot. But is we need to focus on tools for making apps, because that's how we're going to share our work with 99% of the earth.
Yes. Yeah. 100%. I totally agree. And lots of props to Keith Russell McGee and the folks over at Beware for doing that, and for you guys supporting that work, because it's one of those things where there's not a ton of people trying to do it. It's not like, well, we're using Django, but is there another way we could do it? It's basically the same thing, right? It's creating a space for Python where it kind of, I know there's PyInstaller and PyToApp, but it's pretty limited, right?
Yeah, there's not a lot of effort there, and so it's there are a few people who've been doing it for a long time, and others are getting more into it, and yeah, so I wish that we could get more focus on it, because there are tools, they just don't get a lot of attention.
Yeah, and they're not very polished, and there's so many edge cases and scenarios. All right, let's close it out. Let's just final thought on this little topic, and then I'll let you wrap this up for us. Do you think that's maybe a core developer thing? I mean, I know it's awesome that PyToApp and PyInstaller and PyFreeze are doing their things, that Toga are doing their things to try to make this happen. But I feel like they're kind of looking in at Python and go like, how can we grab what we need out of Python and jam it into an executable and make it work? Like, should we be encouraging the core developers to just go like a Python MyScript -- Windows and then out you get in .exe or something?
I don't know, actually. That would be a great question. Actually, I would ask Russell that question. He would have probably better perspective than I would. Because at some level, it is a tool that is dealing with a lot of problems that aren't core to the Python language. And so maybe having it outside is helpful. But maybe there are other things that the core could do to support it. I mean, again, a lot of it has to do with, the realities of when you drop an application onto a system. You need it to be self-contained. You need to, sometimes you have to, do you have to trick the import library to know where to find things and all of that?
That's exactly what I was thinking, is if Python itself didn't require like operating system level fakes to make it think, if it could go like, here is a thing in memory where just import, this is the import space. It's this memory address for these things. And we just run from the exe rather than dump a bunch of stuff temporarily on disk, import it, throw it, like that kind of weirdness that happens sometimes.
Yeah, there is probably definitely improvements that could be made to the import mechanism to support applications.
Yeah, exactly. Well, we've planted that seed. Maybe it will grow. We'll see. All right, Stan, this has been an awesome conversation. Give us a wrap up on all this stuff, just like sort of final call to action and summary of what you guys are doing at Anaconda, because there's a bunch of different stuff we talked about that are in this space.
Yeah, I mean, mainly I would say I would encourage people that, if you want to speed up your Python program, you don't necessarily have to leave Python. Go take a look at some of these tools. Go, measure what your program's doing. Look at tools like Numba, but there are other ones out there, PyTorch and JAX and all sorts of things. There are lots of choices now for speed, and so Python doesn't have to be slow. You just have to sort of figure out what you're trying to achieve and find the best tool for that. So, one other thing. Do want to shout out, I'm teaching a tutorial in a month over at the Anaconda sort of live tutorial system, which will be how to use Numba. So if something you saw here you want to go deep on, there will be a tutorial, I hopefully linked in the show notes or something.
Yeah, no, I can link that in the show notes. No problem. Absolutely.
Yeah. So I'll be going in.
Is that the high performance Python with Numba?
Yes.
Thing?
Yes. So we'll be doing worked examples, and you'll get to ask questions and all that stuff.
Cool. I'll make sure to put that in the show notes so people can check it out.
Cool.
All right. Well, thanks for sharing all the projects that you guys are working on and just the broader performance stuff that you're tracking.
Yeah, awesome. Glad to chat.
You bet. See you later.